And g'day to everyone up there at Barellan. It's Graeme Anderson here from Agriculture Victoria with a quick climate update. With Agriculture Victoria, we put out seasonal forecast newsletters like the Break, which is monthly commentary on seasonal outlooks. We also do soil moisture probe work and a lot of climate talks, but there's also a new GRDC funded project to extend some of this seasonal forecast commentary to southern New South Wales. So I'll show you that in a minute too. Here's a great tool when you're looking at rainfall and trying to make sense of everything. Climate, you can download it on your phone or you can use it from the desktop. It's got heaps of sites where you can download the rainfall. I've downloaded the Barellan post office here, and you can do things like how's the season. So this is going back from January last year. This is sort of long-term average. These are all the previous years, and that the red is just how that last 14 months is tracking. So that's a pretty extraordinary dry period, and you're in the the driest 5% of years. So he's hoping that improves soon. It's a good app. You can do all sorts of queries with it. One is you can say, well, how often do you get 25 mil of rainfall over a 7-day period in March and April? In that record at Barellan, when it looks at that, it says it happens about 50% of the year. So often, as keen as we are on autumn breaks, it's always good with a tool like this. You can just work out how often has these things happened in the past. So anyway, download it, have a go. That's a good tool. Here's a long-term rainfall record from Barellan. It goes back to 1878, and this is the long-term average here, 438 millimeters of rainfall right through up to last year. You can see some years, over 700 or even 800 mil, and then other years, can barely crack sort of 200 mil. So big range there in variability, and you can hit pause on this and just sort of discuss if you can see any trends or dry bits there. I guess one of the things I'll just be talking about is what's the difference between some of these wetter years and dry years in terms of core climate drivers. Here's that Barellan record looking at summer, autumn, winter and spring, pretty evenly distributed throughout all of those seasons. Plenty of variability there. I guess one thing we just probably point out, autumn in a lot of Southeast Australia, autumn's been the one season in the last 20 years which has been perhaps behaving a bit less reliably than it once was. But plenty of variability in the rest of that record. Okay, so where does all that moisture come from and what's behind our wetter and drier years? Well, the warmest oceans are along the equator, and that's where they generate the most tropical moisture and cloud. And this is basically a satellite image of precipitable water, and it's kilograms of water per cubic meter of air. So you can see here, most of it's along the equator, and the whole thing about wetter years is when we've got more of this moisture happening to our north, which feeds into our weather patterns swinging across here. And you can see here, this is a view from the southern end of the planet. There's Antarctica. You can see the big Pacific Ocean. We've got the El Nino Southern Oscillation out here. The trade winds blow towards Australia. They're a good supply of moisture, but every now and then they can break down. And if the trade winds head the wrong way, like they do in El Ninos, then that's not helpful for feeding moisture in. But basically, for the weather events through here, we're after a good source of moisture, and we either get it from the Coral Sea, to our north, or the Indian Ocean Dipole is a useful one too. So in 2016 it was sending plenty of moisture feeding into sort of cloud bands that came across Southeast Australia, and then of course last year the Indian Ocean Dipole sort of went into its drier phase a bit. So these two are really important to watch when in wetter years, when they're both sort of sending plenty of moisture. They correlate to really good seasons, and then when they're both when there's less cloud and moisture up here and the oceans are cooler, then that's not a good sign. And that's what a lot of the seasonal forecasts look at. You can see down here the southern annular mode, which is one of the key drivers of the sort of colder air, and it's where that colder air crashes into this feeds of moisture that give us those wetter years. Here's a sea surface temperature map. Along the equator, the water's a lot warmer than it is down south, but this is an anomaly map. So this is areas where the ocean might be a couple of degrees warmer than it is normally, and these blue areas are oceans that's cooler than it is normally. So this is going back to spring 2006. This is what a dry pattern looks like. You can see an El Nino here in the Pacific. There's lots of extra cloud and moisture, and there'll be floods in Peru, everything happening there. But to our north, we've got cooler sea surface temperatures and average, a lot of blue sky, and just means less moisture feeding into the rain events down in southeast Australia. So that's one of the things season forecasters are looking at. If you look at this area to the north of Australia, and I'll show you what a wet pattern looks like. So there we go, there's the October 2010, pretty wet year, big La Nina in the Pacific. All the warmest water though was in our part of the world. So warm sea surface temperatures, heaps of extra cloud and heaps of moisture feeding in to those weather events. And then it was just a matter of the weekly weather event about whether it fell on your farm or someone else's. But that's pretty much the difference between the wetter and drier patterns. So when we look back through longer term record, a third of years are dry, a third are wet, and a third are average. And we're going to just look at how has past El Nino years or Indian Ocean Dipole years affected winter spring rainfall at Barellan. Okay, so here we're looking at the previous El Nino years at Barellan. So we're looking at August, October rainfall. Now there's been 30 El Nino events in that long-term record, and instead of a third of those years being decile 1 to 3, in the red here dry, 2 out of 3 were dry. So it doubles the chance of a dry year. So whenever you've had El Ninos in the past, this is what's happened, double the chance of drier, but still importantly a third of those El Ninos were okay with either average or wetter seasons. So that's for August, October rainfall. Also when you look across, whenever there's been the Indian Ocean Dipole in its drier phase, in that positive phase, it really increases the drier years too at that Barellan for August, October. Still a chance of average or wetter, but increased chance of drier. When you've got the La Nina at Barellan, 36 events there, and that doubles the chance of a decile 8, 9, 10 spring in the blue, and IOD negative when it's sort of wetter up there in the northwest of Australia, it actually feeds in extra moisture too. So it doesn't, none of these guarantee wetter or drier, but they certainly change the odds. So that's sort of what's behind good old-fashioned variability. Is there anything different to good old-fashioned variability happening? So here's one thing that's pretty different. It's temperatures for the last 100 years from the Bureau, and you can sort of see summer, autumn, winter and spring, quite a lot of variability there, but you can sort of see winter's milder, probably get a bit better growth in winter, but there's a bigger summer coming, and we just had a pretty extraordinary hot summer, happening more reliably. We used to have hot days in the past, but not as reliably as what we're having them now, and so spring too, when you look at spring, the last 10 years, you know, there's been quite a lot of springs between 1 and up to almost 3 degrees warmer than average. So basically what's happening is we're squeezing in an extra month of summer, and that's sort of summer's sort of hanging around a bit longer into autumn and turning up a little bit earlier in spring, and that's a trend that they expect to continue in the coming decade or two. Another thing that's a bit different, this is work by Dave Stevens in Western Australia, but basically looking at seasonality of rainfall for the last 100 years prior to the year 2000. He looked at seasonality of rainfall, what were the summer dominant rainfall zones and what was the winter dominant zones. When he's looked at that for the last 16 years, he's sort of seen most of those zones have shifted south. So the summer dominant zones shifted south a bit, and this sort of uniform zone, it's shifted a fair way south as well now. So that's one thing that's a bit different, and it's interesting that with sort of climate change, that's sort of what they were expecting. So those trends are likely to continue. I guess there's profitable agriculture happening all through these different climate zones. So the challenge is just really about how we adjust to different zones as those changes happen. Another thing that's a bit different, this is pressure pattern over all of southern Australia for the last 50, 60 years. So you can see the pressure goes up and down quite a bit, but there's a clear trend there. Again, that was expected with their climate change models. So we've got increasing pressure in southern Australia. That's probably what's squeezing out some of those autumn rainfall events. And also one thing that's still happening with this increased pressure pattern is when we get the high pressure sitting in the right spot, we can still bring in super dry cold air, which helps create some of those frosty conditions that we're getting. So that increased pressure pattern is something that's a bit different. So going to run through a couple of forecast tools. Few here that I like. This one's the chart bureau from the bureau. You just hit play on that and it'll run through the next 7 days of weather. It's a good one. There's also the bureau's water and land 4 and 8 day rainfall, and I'll talk about why I like that one. There's the Met Eye as well. It's interesting, increasingly with forecasts, it's important to know with the phone app or whatever forecast you're using, where's the model come from. Here's an example from a weather event last year. This is from the Bureau's weather forecast model, but here's the European model and here's the US model. And you can see quite often farmers can have different models that feed into their apps. So one farmer might be comparing theirs to their neighbours and they're both getting told slightly different things. So no one can accurately predict I guess the future, and that's important why with these models you at least know which one you're getting. And also for rainfall events, it's good to tap into tools where there's a bit of consistency around what the models are telling you. And that's why I like this water and land model. This one that the Bureau has, it's got 6 of the world's leading rainfall models, and so for the 4 and 8 day forecast it sort of puts them all together on the one map. So it's a really good guide. Where it probably doesn't work as well is where there's sort of forecast thunderstormy conditions, because thunderstorms are really quite variable in terms of, you can go a short distance and a big variation in rainfall, but for the more general rain events, this model tool is really good. Another key thing when we get beyond the weekly forecast, when talking about seasonal outlooks, there's a lot of talk about probabilities, and I know that's a bit tricky to understand. And so here's an example of a map from last year, and you look at this sort of a map, and they're saying, well, there's an increased chance of drier, and basically saying that there's only a 30% chance of exceeding median rainfall. Which is the same as saying there's a 70% chance of being drier. And how the models sort of get that is they might run the forecast models 100 runs, and out of 100 runs for a particular area here, 70 might have come out at drier and 30 might have come out wetter. So the important thing with these is that looks like a dry forecast, but there are still model runs in there which have actually been wetter. So it doesn't guarantee dry, it just says that there's more odds heading into that dry territory. And this is the new product that's out for Southern New South Wales. Dale Graeme puts that together with Agriculture Victoria, and GRDC has sponsored us to do that for Southern New South Wales this year. So I'll explain what it is. It's like a footy tipping sheet for 12 global forecast models across the world, and Dale looks at Southern New South Wales, and here's the European model, the Bureau's model, JAMSTEC in Japan. There's a couple from US, NASA, another one from Japan, China, UK, Met Office, so a bunch there, the Queensland phase system. This is the February runs for March, April, May, and he's looking at what each of them is saying about the Pacific. So a few of them are thinking, potential El Nino, but it's not there yet. The few of them thinking the water might stay warm for a while in the Eastern Indian Ocean. But here's where he looks at Southern New South Wales and say, well, how many are saying wetter or drier or average for the next 3 months? So you can see here there's a mixture of average and wetter, and quite a few there with some hints of drier. He puts a bit of a summary table there, so you can see the 7 on average and a couple on drier, but most of them are on warmer. So that's their sort of outlook for the next 3 months. We find these pretty useful to look at, and certainly when more than half of them start to be in the sort of drier or wetter, when you get a bunch of models all starting to think that, that's when we tend to pay more attention to them. So there's a few hints of dryness still there. Autumn's a pretty unpredictable time of the year. It's often very event driven, but we find these forecasts tend to be a bit more useful or reliable when you're getting into winter and spring, and especially as these forecasts change from month to month, you can start to see if what was predicted the previous month is starting to happen, and you can see sea surface temperatures change, and you can see cloud patterns change. Then you sort of start to be a bit more confident in the forecast. So lots of great stuff farms are doing to deal with variability, you know, modern R&D, improve on-farm infrastructure for water and fodder, and there's lots of upsides to agriculture, but we certainly know that there's a lot of challenges in dealing with greater variability, and one of those is really important is improving business management for dealing with variable years and incomes. So that's happening right across Australia. Farms are looking at how they can do this better. Also looking at managing farms for dealing with when we're at the extremities of either dry or wet, because that's often when there's the most pressure on farms. And the key thing is being linked into good networks and knowledge channels, and doing what you're doing today and having your workshops and sharing what's working and what isn't. So I hope that's been useful. If you want to subscribe to that break, get that monthly update, just drop an email to the break at ecodev.vic.gov.au. There's also climate dogs and some other tools which I'll send to Laura, and she can show that at the workshop. So all the best.